Hey guys, so we're going to be reviewing exponent rules today. So those of you may have remembered them in previous math classes. Those of you that haven't remembered them in previous math classes, you are in luck because we're going to be learning all 6 exponent rules today with a few practice problems. So if you can pull out your note page that was given to you in class, we're going to be filling out the rule section and we're going to be doing 3 of the 6 practice problems today in this video. So if you want to follow along and fill that out, that would be excellent. So our first rule for our exponents is the product of powers rule. So product of powers rule basically states that if you have two bases that are the same, those would be, in this case, would be the a's, and they're being multiplied together, you can add the exponents, so m plus n. So in our example here, we have x to the third times x to the 10th. So we can add 3 plus 10, and my final answer would be x to the 13th. Our next rule would be the quotient of powers rule. So the quotient of powers rule is when we use division, again using the same base, those being a's, we can subtract our exponents, so m minus n. So in this example, again, we have x to the third over x to the 10th. So 3 minus 10 would give us negative 7, but we're not allowed to keep negative exponents, and this will be explained in Rule 5. So therefore we have to convert this to 1 over x to the 7th. And those of you that forgot negative exponents, again, don't worry, we'll be explaining this in Rule 5. Rule number 3 is power of a power rule. So it basically states that when we have an exponent raised to another exponent, we can multiply those two exponents together. So in this case, x to the third raised to the 10th power. So 3 times 10 would give me 30. So be careful here. This is confused a lot with rule number 1. So we do not want to add the exponents here, like 3 plus 10. We want to multiply. So make sure that you are doing it correctly. Rule number 4, kind of similar to rule number 3. So this is power of a product. So essentially it means that you need to distribute that exponent outside to everything that's inside of your parentheses. So this includes the a. I see so many students that do not distribute it to the first coefficient. So please, please, please make sure that you're distributing it to the a and to the b exponents. So in our example here, we have 2x to the third power raised to the 5th. So we'd have 2 to the 5th power, which would be 2 times 2 times 2 times 2 times 2, which will give me 32, and then 3 times 5, which would give me 15. So our final answer would be 32x to the 15th power. Our next rule, which I talked about earlier, is our negative exponent rule. So we're not allowed to have negative exponents in dealing with exponents because it's not something that actually would be feasible. So we have to change that or convert it because it's going to convert to a decimal. So we would always put it underneath 1 or underneath the coefficient if that is not raised to the negative power. So in this case, we have x to the negative third. So this would give us 1 over x to the third power. Our last and final rule that we're going to cover today is our zero exponent rule. Personally, it's my favorite. Anything to the power of 0 is always going to be 1. So in this case, we have combined rule number 1 with rule number 6. So x to the negative third times x to the third power. So negative 3 plus 3 will give me 0, and anything to the power of 0 will always give me 1. So that means, yes, if you have a huge complicated problem and it's raised to the 0 power, the answer is 1. So again, make sure that you don't give me 0 here because there's so many students that forget. Again, anything to the power of 0 is going to be 1. Now, if you've written all those 6 rules on your note page, we're now going to transition to our practice problems. So this will be in our next box or our examples. So I'm just going to be basically showing you these examples, but I really would like you to spend the time to work them out and then submit the answers to me. And we'll go over them tomorrow in class. So our first example uses a combination of a couple different rules. So we have 2xy to the second raised to the third power. The one thing I want you to make sure here is make sure that you're distributing the 3 to the 2, to the x, and to the exponent of 2. So you should really have that 3 in 3 different spots. So don't forget that x, even though it doesn't have an exponent, that's an invisible exponent of 1 here. So when you're doing example 1 problem, make sure that you make sure that you use the exponent of 1 for the value of x. Okay, example 2. Again, we're using a couple different properties here. So we have 3a squared b cubed times negative 3a b squared. So again, you want to make sure that you're multiplying those coefficients. So 3 times negative 3. And then remember that when you combine the exponents for the a that's next to b squared has an exponent of 1. So you have a2 plus a1, which would give you a to the third. Okay, so just be careful with that example. Last example is using our quotient rule. So on this one, again, remember about the negative exponents and how you cannot keep your negative exponent. And then also remember that you want to reduce your numbers in front or your coefficients. So 3 over 9 is not going to stay 3 over 9. You're going to reduce that to the lowest possible fraction. All right, and that concludes our review of exponent rules. I'll see you tomorrow in class.